Now, how do you find out oxidation number of radicals? Now, let's first of all find out the radicals and see. SO4. Now, SO3 is not a radical because the oxidation number here is 0. The oxidation number is 0. SO4, the oxidation number is 2 minus. CO3 is 2 minus. NO3 is minus 1. But in mathematics you don't show the coefficient when it is 1, you just show the sign. So from 2 above you show coefficient. Now PO4, 3 minus. Then we have SO4, CO3, NO3, PO4. These are majorly the radicals. Then we have OH minus. We also have NH4 plus. These are radicals, a group of elements carrying charges. Now, how do you now know? How do we come about? How does this 2 minus come about? How does this come about? How does this come about? How do you find out or calculate for this? And that's what we're about to do now. Quickly, let's look at how this is not a radical. This is just a compound or a gas of the sulfur and oxygen, a sulfite gas. We add up. The step 1 is you sum up the valence electron of all the elements in the group, and then you see if it is obeying octet, or not. Then what is the number left for octet to be reached, and that will determine their valence number or their charge. Now for SO2, the valence number, sulfur is in group 6. So the valence electron in sulfur is 6. Valence electron of sulfur is 6. Plus valence electron of oxygen, they are in the same group, is also 6 times 3. We have 3 electrons. 3 atoms here. 6 times 3, that's 18. 6 plus 18. This gives 24. 24. So if you have 24, how many octet states can be found here? That is 8 divided by 8. 8 here 1, 8 here 3. It is evenly distributed. So there are 3 octets in 24, leaving nothing left. So if 8 is in 24 3 times, that means 0 is left. No space is left. No valence is left. No electron is left out. Therefore, making that one makes SO3 a neutral compound. So the oxidation number or the charge here is 0. So it is a neutral element. So SO3 is not a radical. So it's out. I hope we are following. Let's look at SO4. SO4, sulfur, 6 valence electron is available. Oxygen, also 6 valence electron, 6, but 4 oxygen atom times 4. So this is 6 plus 6 times 4. This is 24. 24. 24 plus 6. This is 30. So there are 30 valence electrons. Now, if we are to divide by 8, we don't have a round figure. So there will be 8 3 times and remaining 6. 8, 8, 8, 24 and 6. So what is left to complete the last octet is 2. So 2 is missing. That is why we have minus 2. 2 minus. And that is why the valence electron is 2 minus, because it is remaining 2 to complete the last octet for SO4, having added up the valence electron. Now let's look at nitrate, NO3. Nitrogen is in group 5. 5. Therefore, having 5 valence electrons, we have 5 plus oxygen has 6 valence electrons. 6 times 3 atoms times 3. This is 18. 5 plus 18 equals, this is 23. So we have 23. Now, 23, how many octets can we get? We have 8 plus 8, that's 16, plus 7. This will give us 23. The last one remains 1 electron to complete the last octet. Therefore, that one is deficient, and that is why the radical or the charge of NO3 is -1. So that is the charge, and this is what determines it. Adding up. Now let's look at one more before we call it a day. For phosphates, let's look at phosphate quickly. PO4. Let's find out the radical. Now, phosphate is in group 5. We have 5 valence electron plus oxygen, that is 6 times 4. 6 times 4, this is 24. So we have 24 plus 5, 29. 24 plus 5, that's 29, equals to 29. This, we have 3 octets here, and then we are left with 5. So for this to reach the final octet, we need 3. So 3 is deficient. 3 electron is deficient. Therefore, 3 minus happens to the charge of PO4 radical. So with this, I believe we now understand how to calculate the charges on each radical. Now, as a take home, and then in the comment section, please find out the radical, calculate the radical of CO3. What radical does it have? And OH minus, no, hydroxide. Find out the radical. Is it a neutral radical or a charged? And this, is it neutral or charged? Then we have NH4. So find out the radical, the charge on this radical, and feel free to put your answer in the comment section. Thank you for joining me today.